In this video we're going to test an energiser, and in this case it's the Stayfix M36R, which is a 36 joule output energiser. We're going to be using the Energiser performance meter, and we're going to be using the external load box. I've also printed off the tech sheet for the 36 joule energiser. In this case it's a speedrite one, but the outputs are exactly the same, which gives us a couple of readings of what the voltage should be at certain loads. So our first reading will be a no load measurement. So with our Energiser performance meter, our probe is in the no load port, our dial is set to no load. If we turn that on, all our other switches are up. If we grab the probes, place them on the terminals, you'll see we get a reading there of 9,000 volts. There's no reading in the joules screen because it's an open circuit, so it's not really working very hard at all. If we then apply load to the unit, so if we go to 1000 ohms, that goes in the 1000 ohms port, the dial goes to 1000 ohms, probes on the terminals once again. You can see our voltage has dropped to 8.6. We're now producing 3.7 joules, 8.8, 0.9 kilovolts, 9 kilovolts, and we're just under 4 joules. So if you compare that to our output guide, so a standard load, 1000 ohms, should be 8.8 kilovolts. We've got 9, so we're around the mark. Open circuit should be 9.5. We were at just over about 9. So yeah, within the ranges. If we then apply more load, if we go to 500 ohms, our probe goes in the 500 ohm port, our dial goes to 500 ohms. Once again on the terminals, reading now goes to 8.2 kilovolts with 6.6 joules. 8.3. So the Energiser is sensing the extra load. The joules has gone up. We're on to 7 joules. We're 8.5. And that's where it's sort of settled. At a 500 ohm load, once again, if we look at our spec sheet, 500 ohms, we should be 8.5, which is spot on to what we've got. So if we put a bigger load on that, we need to use the external load box because this Energiser is above 12 joule output. So our probe goes in our no load or external load box port. This switch goes to load range 2, which is our external load box, and we're going to put 100 ohms on it so we can turn our dial to 100 ohms. We now apply this to the terminals, and we put our probes back on the terminals again. Now the Energiser will take a while to settle on a voltage and a joule output as the Energiser senses the extra load. It's working out how hard it needs to work to maintain that voltage. So as you can see, we're 5.1 joules with 5.4 kilovolts. Those joules are slowly starting to climb. 5.6, 5.7. It's working harder. What we should see is this Energiser switch gears. There we go. Our end light on our pulse bar has come on. Our joule rating has gone up to 10. We're 8.1 kilovolts. So what that means is this Energiser is working as hard as it can to maintain that 8,000 volts. So if we were to add even more load, we'd just see the voltage start to drop now. You don't want to leave that load on there for too long because these load boxes can get hot and burn out. So that's testing the Energiser. Of course, you can use just your standard voltmeter to test an Energiser, but of course it's just going to be open circuit, you can't apply a load to it. So by doing this test, you're proving to a customer that the Energiser is working the way it should. So if the farmer's having issues with a low voltage on a fence, it sort of comes back to issues around earthing or maybe fence design. So it's really just there to prove that the Energiser is doing what it's meant to do. That's it for this one. Don't forget to like, comment, subscribe.